Hello everyone, welcome to today's hands-on session. In this exercise, we will be diving into some practical Python programming tasks around Pandas, primarily centered around data manipulation and analysis using Pandas. Here is what we will be covering: creating and managing data frames. We will have several examples where we will take data from CSV file. We'll take data from tabular data structure, and then we'll see how we can create and manage our data frames. Then we have data manipulation, where we will learn how to filter specific data and perform operations like maximum finding maximum values, sums, and medians. We'll also be doing several of those advanced operations where we will sort data, handle missing values, and calculate the statistical metrics like mean, median, modes, and averages. We'll also have a final brief look at our integration with MySQL, where we'll explore transferring sorted and updated data to a MySQL database. By the end of the session, you'll have a solid understanding of how to manipulate and analyze data in Python and seamlessly integrate it with database. Let us get started. First exercise that we'll be doing today is a case study as covered in your textbook, and this is based on an open data set from UCI. Uh, Here we'll be talking about one of the data set which is called Auto MPG, and this data set is related to fuel consumption by automobiles in a city. Consumption here is measured in miles per gallon or MPG, and then it is having you know uh, data captured on several other attributes, that is MPG, cylinders, displacement, horsepower, weight, acceleration, model, year, origin, car name, uh, where cylinder, model, year, and origin have categorical value, and car name is a string with unique value for every row. Remaining attributes have numeric value. We have downloaded this data from there, and we'll do some of the suggested exercises. So just to start, I have actually put it in a file where in my local directory with this name auto plus mpg, and you can look at it. So we are having several of these files. We are going to work on data dot original, this one, right? Auto mpg data dot data, then hyphen original, and the reason is otherwise the data is curated for some of the operations that this particular exercise is talking about. So this is saying that load this particular data into a data frame named AutoDF, give description of generated data frame AutoDF, display the first 10 rows of the data frame AutoDF. How you'll get all these three done? Now this is also the time where you start repeatedly use your pandas utilities, right? So to load, this is a data set which is in txt format, and here if you look at, there are more than one or more uh, you know uh, empty spaces, right? And so we are simply calling it through pd.readcsv. We have chosen our file name here, and we are simply calling through pd.readcsv, where we are giving our file name and separator as s plus, right? So which will means that one or more spaces, right? and then we are saying that header is not present. We are actually setting up our column based on the description that you are seeing here, as well as in a file out there. We are actually going to set across these 10 12 columns that we are having, right? So we'll set auto ref here. Now once you do it, right, uh, you know pd.read csv is anyway give you the data. So part one is done. For description we can actually print dot description, we'll see that. And to see top 10 rows, we have just done head is equal to head where n is equal to 10, right? So as you can see, right, top 10 data set across these cylinders, displacement, horsepower, weight, acceleration, model year, origin, and name, right? So far, all the values seems fine, um, but now let us look at AutoDF dot describe, right? So here you can have idea about 398 rows, right, for MPG, uh, cylinder displacement, everything, right? So it means that MPG might be having some missing. Horsepower is having 400, so this also indicates that horsepower might be having something missing. And then you have idea about mean, median, mode, quantile, and max. Now, first of all, we are going to talk about several exercises. Find the attributes which have missing values, and then it is saying that fill that value with the prior data, and then it is saying that remove the rows having missing values from the original data set. Now, if you look at top 20, thankfully we can see many of our this 10 to 15, right? So you can see the nans out here. Most of the nans for MPG are here. Most of the nans for horsepower are not here, but we can find them. So with that in mind, we'll actually also test it, right? So replace the missing value, what we can do. So first find it out, what all are the missing value. And what we can do for that, we call is null dot sum on the whole data set, right? After executing it, you can see that your MPG, right? MPG here, MPG is 8, and then your horsepower is 6. It means that 8 MPG and 6 horsepower data are missing. Now for MPG, if you want to fill, it is saying that fill with the previous available data, right? Right. So method for this is we actually look at that particular column and call fill NA with method is equal to backward fill. If it was asking to fill it with the next one, you could have actually used forward fill or F fill here, right? Now then we have actually printed all the values, and then we are actually printing say 10 to 19 records of this. For time being, let us keep actually other things aside. So what you see is from 10 to 19, everything is 15 for MPG. And MPG df.isnull.sum is now 0, which used to be 8 here, right? As you can see the records here, right? All the nulls were actually between uh, this 10 till 14. And what was the prior value? 15. So in backward field, all of this will go to 15. 17th one will be having 14 because that's the value out there. So we'll also test it. You see here, this is 14th, right? This particular record, this one, right? Everything else is 15. Okay, now with that, we can actually execute our other part, where we can look at, the second one, which is horsepower, right? Which is empty. So let us say we are actually, kind of looking at here again the same. In horsepower, we do our fill and as backward fill. So here is the API to call it, right? You actually get that particular series by referring to the column name, then call the fill NA, and inside that you can give method is equal to this, right? We are assigning it to some other because we don't want to modify. Otherwise, in place is equal to true. We'll do the modification here itself, and eventually we are going to remove this auto drop NA in place is equal to true, which will actually be removing everything that we don't want, right? So as you can see here now, post correction, all the data sets are fine, and you could have actually checked the data set which are, but we can trust because so far we have already seen it. So here if you see, now we'll actually drop all the rows with NH, and we have actually given n plus is equal to true. So this particular data set will be now all fixed. The next question that it is asking is print the details of the car which gave the maximum mileage. How you'll get the maximum? By calling the max on that particular series. So AutoDF MPG, this is the MPG. So mile per gallon, right, is the mileage, and maximum mileage will be what? The max of it. So we have actually assigned it in max MPG, and then we are saying that in AutoDF, where AutoDF.mpg is equal to max MPG, right? So we are actually filtering all the record with this particular. So as you see here, we have actually got this 329th record, where which is which max power, max MPG is 46.6. So the next question is find the average displacement of the car given the number of cylinders. So how you can do? Given the number of cylinders means we have to group by cylinders, right? And there on displacement we can apply aggregate on mean because it's asking for average, right? If you execute, you'll see that now we have actually grouped the cylinder 3, and displacement is 72 for 409, blah 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 till 8, right? So you can see now how the grouping is happening, right? Group on cylinder, and then on that for displacement it is actually calling it aggregate of mean. Now what is the average number of cylinders in a car? How you can get it? Just on the cylinders you can call the mean, right? So 5.4, right? The answer. Determine the number of cars with weight greater than the average weight. So first you get the average weight. How you will get the average weight? By calling mean, right, on this particular series. And you have got the average. Then you simply, it is asking the number of cars. So you are actually looking at length of this particular, right, data frame where my weight is greater than average one, right? So average weight as we have printed is 2977, and there are 170 cars as you can see. Out of 398, 170 are having higher weight. This was an interesting exercise where we took real life data set up as a case study in a textbook. We actually loaded that, cleaned it up this bit with where we cleaned up some of the NH, and then we actually did some good aggregation around max, mean, group buys to answer actually some practical question related with case study. Now we'll move on and take another exercise unsolved from your textbook, where we have been given this table product, and it is asking that write lot of code around different things which you'll see later. But this is having actually 4 by 4 table where you are having information about item, company, rupees, and USD, right? And items are TV, AC, as you see here. So TV, AC. Company is actually say LG Videocon, LG Sony, and the cost of it in rupees and cost of it in USD, right? Don't go for why USD is rupees in not in exchange. I mean, just trust the data the way. So now how you'll get it created data frame? So you can actually create dictionary for items, for company, for rupee, for USD, and you can actually create the data frame by calling pd.data frame on that dictionary. That's the easiest way here. So we have actually got our data in a dictionary format where we are providing key and the list of values out there, right? And then you simply call product df from pd.data frame, and we have got this ready. So whatever table that you want. So this is done. First part is done. Now so to create the data, from the above table, to add the new rows in the data frame, they have not given anything new, but we can actually simply, as you know, how what we can do, we can concatenate, right, vertically. Now to display the maximum price of LG TV, this is very interesting. So it means that LG is under company and item is under TV. So and then maximum price you can choose. Let us say you choose rupees, right? So what do you want? You want it to be grouped by item or company, whatever works, because you have to actually find, uh, LG TV, right? So all the TV, it will be grouped by TV, and then there will be grouped by say company. So you get two TV and then two LG, and then a TV and a Videocon and an AC and a Sony, right? That's how you will get your data set. Now there, if you aggregate, on rupees, right? What is the question here? Question is display the maximum price. So you get the max, right? You get an aggregate on max on this group. Your group by is ready, right? When you have got all the group by according to item and company, and then you have got your max for that group, and then it is asking that give me the item which is actually for LG and TV. So what you can do, you can apply the dot loc, right? Dot loc, right, locators, and provide the tuple TV and LG in that, right? So as you see here, what we have done is, first you get your product DF, right, and then you have to apply your group by. If you are not able to follow me, yeah. So waiting. So okay, now hopefully you'll be able to see the first thing on your screen, right? So product df dot group by item and company, and then we are actually working on column rupees, and then calling dot aggregate and which utility of it maximum, right? Now we got our group df. In this we are calling that give us a combination for TV and LG, because we are looking for price of maximum price of LG TV. So that's 15,000, as you can see. Then it is actually saying that, cost of all the products. How you can get it? On the rupee column, you simply call the sum. You got it. And then it is saying that median of the USD of Sony products, right? So median of the USD. How you'll get median of the USD of Sony products? So if you look at Sony, right? Sony product will be under company. So it means that, uh, yeah. So right now we just have, yeah. So that's why we are getting it already. We have got correct answer, which is 725. Because why it is 720? So how you can get it? Since there is only one data, so you can simply filter it on company, right? And then on USD. So you can actually group by, right, a company, and then call the median, right? And then on that median, you can take your term for Sony and USD. Let us try that if it works. So let us increase it. So product DF, let us say um, group median, right? And what we are doing here is in our product DF, right? We will call our group by, right? And where this group by is going to be? This group by is going to be on company, right? So basically we can see, because anyway we are going to use USD, so we can simply call it on company, uh, and then on USD of it we'll get the median, right? So this is perfect. um, then what you get here, let us print the group median. You got by company, right? Sony TV, everybody, right? And then what you can do here is access the LOC. You have to access the LOC of what? Which tuple? You have to access the USD. You have to access this for LG, right? So if you see here, LG, right, and let's see what happens. 750, right? So because there is only one entry, it could be interesting to see if there are more companies out here. Oh, ho, ho, ho. For LG, we have got 700 and 800. Yeah. So that's why we are having 750. You got it? There were two entries, 700, 800, and so you got 750. Great. You got it correct. Now it is saying that sort the data according to the rupees and transfer the data to MySQL. So to sort it on rupee, what you can call dot sort values, and you can provide y is equal to the column that you are having, right? So you got the sorted data. Now from here on, what you can do is, you can actually you work with your MySQL connector and transfer it using to SQL and the other interface that we are talking some time back. So that if need be, just you guys feel free to provide comment if you see difficulty making this setup. I will actually spend some extra time and create um, the it is the remaining part of this tutorial, where we'll actually show that how we can actually pass on some of the modified data back in the SQL server, right? With that, I think we are good to stop here. We actually again reviewed and looked at two interesting exercises, one case study and one tabular data, and we did good exercise of group by and some of the others one. So with this, we have come actually close to large part of what I wanted to cover for you on Pandas, uh, basic as well as advanced. I am still having one topic left, which is actually pivot table, which is important little bit from your exam perspective and a very very practical utility in real world. So I'm excited to bring in some example from that. Uh, but now you are actually kind of equipped well to cover, to score well in your exam with the set of topics that are, frequently being tested. And in that perspective, I'll be actually setting up couple of videos to solve your question paper, primarily around Python, SQL, and more importantly on the aggregation part that we are just learning. So do like and subscribe so that you get update, timely update. Thanks for being till the end.